For billions of years, our solar system existed in isolation. 8 planets, countless moons, asteroids and comets, all born from the same cloud of gas and dust that formed our sun. Everything in our cosmic neighborhood shared a common origin and followed predictable patterns. Until 2017, when astronomers detected something impossible. An object beyond our solar system, from another star entirely, had breached our celestial borders. Its trajectory defied explanation. Its properties contradicted everything we understood about interstellar visitors. And as scientists scrambled to study it during its brief passage through our system, one disturbing possibility emerged. What if it wasn't natural at all? October 19th, 2017, at the Pan-STARRS Observatory atop Haleakala in Hawaii, automated telescopes scanned the night sky, looking for near-Earth objects, potential threats that might one day collide with our planet. But the object they detected that night wasn't headed toward Earth. In fact, it wasn't behaving like anything ever observed in our solar system. Initially designated as A2017-U1, this mysterious visitor was moving too fast. At over 196,000 miles per hour, it far exceeded the escape velocity of our sun's gravitational pull. Most importantly, its trajectory wasn't the elliptical orbit of an object born in our solar system. It was a hyperbolic path, the unmistakable signature of something that originated from interstellar space. Within days, the object received a new designation, One-Eye Oumuamua, the Hawaiian term for scout or messenger from afar arriving first. And Oumuamua was unlike anything astronomers had ever studied before. But the real shock came when scientists tried to understand what this object actually was. Based on its brightness, we initially thought it was a typical comet about half a mile long. But there's no cometary activity, no gas or dust trail as it approached the sun. That's extremely unusual. And these light curve readings, they suggest it's tumbling and possibly elongated to an extreme degree. As the world's most powerful telescopes raced to gather data during Oumuamua's brief visit, a bizarre picture emerged. This wasn't just any interstellar visitor, it was something that defied conventional explanation. Based on the way Oumuamua reflected sunlight, astronomers determined it had an extremely unusual shape, potentially 10 times longer than it was wide. Initial calculations suggested dimensions of roughly 800 meters by 80 meters, giving it proportions like a cosmic cigar or pancake. Nothing in our solar system has this shape naturally. Asteroids and comets tend to be roughly spherical or potato-shaped due to gravitational forces. An object this elongated should be structurally unstable over long periods in space. Harvard professor Avi Loeb was among the first to point out its anomalies. When you look at the shape that was inferred for Oumuamua, it's very different from objects we've found in the solar system. The strangeness didn't stop there. Oumuamua displayed a reddish hue, similar to objects in the outer solar system that have been eradicated by cosmic rays for billions of years. This suggested Oumuamua was ancient, possibly billions of years old. Furthermore, Oumuamua was tumbling, rotating chaotically around multiple axes rather than spinning uniformly. This tumbling motion suggested it had experienced a violent collision at some point in its history. But it was Oumuamua's reflectivity that truly puzzled scientists. It was far more reflective than typical asteroids or comets, almost like a metallic surface reflecting sunlight. When we combine all these features, the extreme shape, the unusual motion, the high reflectivity, we're left with something that doesn't match any natural object we've ever studied. As puzzling as these physical characteristics were, they paled in comparison to the greatest mystery of all, Oumuamua's impossible trajectory. When an object passes near our sun, its trajectory follows predictable physics. Gravity pulls it faster as it approaches and then slings it back out into space at a calculable velocity and angle. But as Oumuamua journeyed through our solar system, something inexplicable happened. It began accelerating away from the sun, faster than gravity alone could explain. In June 2018, a team led by Marco Micheli of the European Space Agency published a bombshell finding in the journal Nature. Oumuamua was accelerating, a small but unmistakable push that couldn't be explained by gravitational forces alone. For comets, this kind of non-gravitational acceleration has a simple explanation: outgassing. As they approach the Sun, ice on their surface vaporizes, creating jets that act like tiny thrusters. These jets leave visible trails of gas and dust, the comet's tail. But Oumuamua showed no signs of outgassing. The most powerful telescopes on Earth detected no gas or dust around it, no tail, no coma, nothing that would explain its acceleration. We've proposed several natural explanations. Perhaps it's outgassing material we can't detect, or solar radiation pressure is pushing it. But the numbers don't quite add up for any natural explanation we've tried. The acceleration mystery prompted some scientists to consider more exotic explanations. Could Oumuamua be a fragment of a disrupted planet with an unusual composition, a hydrogen iceberg that releases no visible gas, or something even more extraordinary? In November 2018, Harvard astrophysicist Avi Loeb and his postdoctoral student Shumel Beely produced a paper that would ignite controversy across the scientific community. Their conclusion was stunning. The properties of Oumuamua could be explained if it were a light sail, a thin artificial structure designed to be pushed by radiation pressure from stars. The concept isn't science fiction. In fact, humanity has already developed primitive light sail technology. The Breakthrough Starshot initiative aims to send tiny light sails to Alpha Centauri, pushed by powerful lasers. Loeb's hypothesis was straightforward. Oumuamua's acceleration matched what would be expected if it were an extremely thin, lightweight structure being pushed by the pressure of sunlight itself. When you leave all prejudice aside and fully consider the observational evidence, the possibility that Oumuamua could be artificial in origin cannot be dismissed. The response from the scientific community was immediate and polarized. Many astronomers criticized Loeb's hypothesis as sensationalistic and premature, arguing that an extraordinary claim requires extraordinary evidence. Invoking aliens should be the absolute last resort after all natural explanations have been exhausted, and we're nowhere near that point with Oumuamua. But Loeb stood firm, pointing out that the scientific community showed a troubling double standard, eagerly looking for techno-signatures around distant stars while refusing to consider the possibility of technology that entered our own cosmic backyard. In the years since Oumuamua's passage, astronomers have worked tirelessly to develop natural explanations for its bizarre characteristics. One leading theory proposes that Oumuamua could be a fragment of a Pluto-like planet from another star system. According to this model, the object would be composed primarily of nitrogen ice, which could explain both its unusual reflectivity and its acceleration, as this nitrogen gradually sublimated in ways invisible to our telescopes. Another hypothesis suggests Oumuamua might be a hydrogen iceberg, a chunk of solid molecular hydrogen that formed in the depths of a giant molecular cloud. As it approached our Sun, hydrogen would sublimate without producing visible emissions, potentially explaining the mysterious acceleration. Yet another theory proposes that Oumuamua might be a fragment from a larger object that was torn apart by tidal forces when it passed too close to its parent star, or a gas giant planet, resulting in its elongated shape and tumbling motion. Each of these explanations has merit, but also significant problems. The nitrogen model requires an improbable amount of nitrogen. The hydrogen iceberg would likely evaporate over interstellar distances. The tidal disruption doesn't fully explain the acceleration. The scientific process continues, with researchers devising increasingly sophisticated models to explain Oumuamua naturally. But a definitive explanation remains elusive. Just 2 years after Oumuamua's discovery in August 2019, amateur astronomer Gennady Borisov made an extraordinary discovery from his personal observatory in Crimea, a second interstellar object entering our solar system. Unlike the mysterious Oumuamua, this object, designated 2I Borisov, behaved exactly as astronomers expected an interstellar visitor to behave. It displayed the classic features of a comet, with a visible tail of gas and dust as it approached the Sun. The contrast between our first two confirmed interstellar visitors couldn't be more striking. Borisov was unambiguously a natural object, a comet from another star that happened to pass through our system. Its discovery confirmed what astronomers had long suspected: interstellar objects regularly pass through our solar system. But this only heightened the mystery of Oumuamua. If Borisov represents the normal type of interstellar visitor, what does that make Oumuamua? Statistically speaking, if Oumuamua represents a common type of interstellar object, we should see many more of them than objects like Borisov. But if our first two detections represent the actual ratio of weird to normal objects, that implies Oumuamua-like objects are relatively common. And that's difficult to explain with our current understanding of planetary formation. The discovery of Borisov emphasized just how peculiar Oumuamua truly was, and reinforced the fundamental questions that continue to haunt astronomers. Today, Oumuamua is beyond the reach of our telescopes, continuing its journey through interstellar space at tremendous speed. We will never be able to study it directly again. But its brief visit has fundamentally changed astronomy. Space agencies worldwide have accelerated plans for survey telescopes capable of detecting more interstellar objects earlier, giving scientists more time to study them. The European Space Agency has even developed the Comet Interceptor mission, a spacecraft that will wait in orbit for the discovery of an intersecting object, then rapidly deploy to meet it. This technological capability simply didn't exist when Oumuamua passed through. Current estimates suggest that at any given moment, there could be thousands of interstellar objects within our solar system, most too small or distant to detect with current technology. As our detection capabilities improve, we may find many more visitors like Oumuamua, or perhaps discover that Oumuamua was truly one of a kind. Meanwhile, researchers like Avi Loeb continue to push boundaries. Loeb has launched the Galileo project, specifically designed to search for evidence of extraterrestrial technological artifacts near Earth. Whether or not Oumuamua was artificial, it taught us an important lesson. We need to be open-minded in our search for knowledge and not dismiss possibilities simply because they seem extraordinary. The story of Oumuamua represents science at its most fundamental, confronting the unknown and grappling with phenomena that challenge our existing frameworks of understanding. Perhaps Oumuamua was simply a natural object with properties we've yet to fully understand, a harbinger of how much we still have to learn about the cosmos beyond our solar system. Or perhaps, just perhaps, it was something more, a probe, a remnant, or a message from another civilization that briefly graced our cosmos shores before continuing its journey into the void. We may never know the truth about our first confirmed interstellar visitor, but one thing is certain: the universe is stranger and more wondrous than we can imagine, and Oumuamua is a humbling reminder that as much as we've learned about our cosmic neighborhood, we've only just begun to explore its mysteries. As we continue to scan the skies, one question remains: what else is out there, waiting to be discovered? And when the next interstellar visitor arrives, will we be ready for it?